Okay, I cannot know if my voice is clear or not, by the way. Okay, great. So we have three states of matter, which are solids, liquids, and gases. Solids are around us everywhere. Solids, it can be like your laptop, your mobile phone, your cup, chairs, everything that you can touch, which is solid. Let's see more closely. If we put this solid under microscope, we can find very, very tiny particles, which are solid particles. Solid particles, as you can see here, very packed together. They have organized the shape, as you can see. As you can see here as well, there are no distances between the particles. They have fixed position. So solids have, they are closely packed together. They have, for solids, they have fixed shape and they have fixed shape. The particles are closely packed together. As you can see, they are very organized. As you can see, there are no distances between the particles, okay? But do you think solids particles can move? Okay, I want you to see how particles of solids can move. Did you notice anything? Okay, actually, solid particles can vibrate in their spot. They vibrate, they shake like jelly. Okay, so they vibrate in their places. So particles of solids at first, they have no distances between them. They're closely packed together in a fixed shape. Also, they vibrate in their spots. There are no distances between them. They have definite shape and definite volume. Okay? When we heat solids, like if we have a cube of ice and we heat it, it will be water, which is a liquid. Okay? So look at the water which is in the cup and look at the particles when we put some amount of water under microscope and we can notice the particles. As you can see here, there are different from solids. These are solids particles, but here, okay, there are liquid particles. Liquid particles are or have not fixed shape, but they have fixed volume. There are distances between the particles, but not very far apart. And this is about the movement of the liquids. Liquids can go past each other. Because of this, we can flow liquids. So liquids, we can flow them. We can pour some water from a cup to another cup. We can drink water. We can pour water. We can pour juice, milk, oil, everything which is liquid, we can pour it. This is because the particles are moving. They are moving past each other. Okay, and of course because there are distances, small distances between the particles. Of course, liquids have not organized the shape like solids. Okay, when we heat water, it will turn into water vapor. So water vapor is a gas. Can you see here the particles of gases? They are going everywhere. So they have not fixed shape and also they don't have fixed volume. The particles are going everywhere, okay? And they move freely. They have not a fixed shape, not a fixed volume, okay? When we heat gases, we can have a state which is plasma, but it is not about our study this year. So we have three states of matter, which are solids, liquids, and the gas. Here are comparison between the three states. Solids, as you can see, the particles are very, very close together. There are no distances between them. They have fixed shape. Also, they have fixed volume. And they are tied in a regular, tightly packed in a regular pattern. Okay? We can hold them and they vibrate in their spots, which means that solids can move. Solid particles can move, but in their spots. But, let me make a thing clear. We cannot, if you have a sheet of paper, the sheet of paper will stay a sheet of paper. But if you cut it, okay, so you make a force, it change. Okay, so solids have a fixed shape, but if it changes this shape, it can be changed, but it will not change by itself. The second state, which is a liquid, can you see the particles? They are closely packed together. They move past each other. They have more energy than solid particles. They have fixed volume, but they have not a fixed shape. Moving on the third state, which has more energy for the particles. They have not a fixed shape, not a fixed volume, and the particles can go everywhere because they have more energy. They can spread out everywhere, okay, in a high speed. These are the three states of the matter. Okay, let's now talk about the changes of the states of the matter. Here we have an example for ice. This is an ice which is a solid, which is in solid state. Okay, after that it can be liquid, can be water, which is liquid, and then when we put this water on the cooker, it will be steam or water vapor, which is a gas. So when ice starts to, or it changes from solid into liquid, this is called melting. Melting. So melting process is the change of the state of the matter from solid into liquid, which is water. After that, when we put water on the cooker or on the stove, it will be, when it boils, it will be water vapor. So the change of the state of the matter from liquid into gas, this is called evaporation. Evaporation. So evaporation is the change of the state of the matter from liquid into gas. But from solid into liquid, this is melting. Okay, when you have a butter or a cube of butter and it turns into, in hot weather, it melts and it turns into liquid butter. Okay, but can we change gas into liquid one more time? Can we change steam or water vapor from gas state into water one more time? Yes, we can, by condensation. We will talk about condensation in the next slide. So from gas into liquid, This is condensation. Condensation. Can we change water into ice one more time? Yes, this is freezing, by freezing or by cooling it. So when we change the state of the matter from liquid into solid, again, this is freezing, okay? So at first, we talked about melting. Melting is the change of the state of the matter from solid into liquid. And this happens by heating. This needs temperature, more temperature. The change of the state of the matter from liquid into gas, this is evaporation. And as well, it needs hot weather, or it needs more temperature. Okay, after that, we can exchange one more time the steam or water vapor into water again. So from gas into liquid, this is condensation, and this needs cooler surfaces like glass. We notice it every day in our kitchen. Also, when we change liquid into solid, this is freezing, okay? This is another explanation for the particles. What do you think these particles are for? These particles are for solids. When we turn solids into liquids, okay, this happens by heating. When we give the particles more energy, it will be liquid, because particles will have more movement, and then it will change to the other state, which is liquid. When we give it more heat energy, it will boil or evaporate, and it will turn into gas state. Okay, from gas into liquid one more time, it needs less heat energy by condensation. Okay, less heat means less movement. After that, when we change liquids into solids again, this happens by freezing. We will put the liquid into less heat, okay, and the particles will have less movement. So 12 freeze will be solid one more time. Great. Now look at the first question that we have from the past paper, but let's make a quick revision on what we have studied today. We talked at first about solids, liquids, and gases. Let me get this slide. Okay, we talked about the three states of matter, which are solids, liquids, and gases. Solids, particles are closely packed together. They have definite shape, definite volume. There are no spaces between them, and they vibrate in their spots. We cannot pour them except powder, okay? When we have sugar or flour, you can pour it because the particles are very small. The second state of matter, we have liquids, okay? So liquids, as you can see, the particles can move more freely than solids. They have irregular shape, not a definite shape, but definite volume. And the particles can move past each other. We can pour them. And the particles have more energy than solids. The third one, which is gas particles can move everywhere, okay? When we put perfume, we can smell the perfume smell everywhere, as the particles can move to all parts of that room or of the place. So gases can move everywhere. As you can see, they have not a fixed shape, not a fixed volume, and they have more energy than liquids and solids. of course, we can pour them as well. And then after that, we talked about that we have the three states of matter. Solids can be liquids, okay, by melting process when we give it more heat energy, and it will turn into liquids, okay? This is called the melting. So melting is the process when we change a solid into liquid by heating. When we give liquids more energy, this happens by evaporation or boiling, and this is the process at which we change liquids into gases one more time. Condensation is the change of the state of the matter from gases into liquids. And finally, we have freezing or solidifying, which is the change of the state of the matter from liquids into solids again. Okay, let's move to the first question that we have today. Gasoline can exist as a solid, a liquid, a gas. Okay, so gasoline is a matter. It can be solids, it can be liquids, or it can be gases. So from solid into liquid gasoline, this is called the process A. Process B from liquid into gasoline vapor, and the process D from vapor into liquid, and from process C from liquid into solid. Let's read the first question. What is the name of the process A in the diagram? Process A, which is this one, okay, from solid into liquid. So what do you think, what is the name of this process? This is called freezing, or this is called melting process. Okay, the slide has been frozen. Let us make it one more time. Here it one more time. Here it is. Okay. So the name of process A, from solid into liquid, this is called melting process. Happen one more time. Okay. This is called melting process. After that, when we have, what is the name of process B? So from liquid gasoline into gasoline vapor, from liquid into vapor, this is called evaporation. After that, after that, what is, I can write it. This is called evaporation. Then, what is the name of process C? This is from the name of process C, which is from liquid into solid. Process C, which is this one. Okay, liquid into solid, this is called freezing, or it has another name for the same process, which is solidifying. Solidifying. Finally, what is the name of process D from vapor, water vapor into liquid? This is called what? Condensation. Condensation. Okay. Moving on to the next question. Okay. Get this slide. Okay. Here, which state of the matter has the strongest forces between the particles? So what is this state? Solids, liquids, or gases? The strongest forces, which are the particles are packed together, they are packed together. There are no distances between them, which are solids. Moving on to the third question that we have today. Draw straight lines to map the state of the matter with the description of the spacing of the particles. So number one, gas. So do you think a gas is spread far apart, gas particles spread far apart, or gas particles closely packed in a regular pattern, or they're closely packed but not in a pattern? So what do you think? Of course, they spread far apart as they have very high energy to go everywhere of the space. Liquid particles, they are, do you think, closely packed in a regular pattern or not in a regular pattern? Of course, in not a in irregular pattern or not in a regular pattern. But solids have a regular pattern between its particles. Let's move on to this question. Some children have built a snowman on a cold but sunny day. Here we have three things which are air, snow, and water. What are the states of matter of the following? Number one, air. Of course, it is gas. What about the snow? Snow is ice, which is solid. And what about water? Water puddles, as you can see, water puddles, these are liquids. Okay, moving on to the next question. What is happening to the snowman in the sun? The snowman in the sun, what is happening to it? What do you think? There is heat of the sun and ice, so it will melt or turn into liquid. Number three, which for the same question, what will happen to the puddle around the snowman when the temperature drops below 0 Celsius degrees at night? What do you think will happen to these puddles? Puddles, these are spots of water that were melted. Okay, what do you think will happen to this water puddles? Okay, below 0 Celsius degrees at night. Of course, they will freeze. They will turn again into solid, into ice. They will solidify. There will be snow again. Okay. Moving on to this question. Okay. Look at this. Look at these particles. What do you think these particles are for? These particles are for what? As you can see here, no spaces between the particles together, no spaces for them. Okay, they are packed in a regular pattern, so of course they are solids, or this is solid. But next one, we have here four particles. Everyone is going everywhere, and they have more energy. They have very big distances between them. So these are gases, or this is a gas. But look here to the third shape particles. Particles are closely packed together, but in irregular pattern. They have more energy or more distances than solid. So this is liquid particles. Okay, here let's draw lines from each state to the description of the particles. So at first, when you says particles are close together, but random, they can move over each other. They can move past each other. So what are they? What do you think? Of course, they are for Of course, they are for what? They are for liquid particles. Of course, they are for liquid particles. Let's make it. Okay. For liquid particles. Then particles are closely packed in a regular pattern. So a regular pattern, but here random pattern. Okay, regular pattern, they vibrate in their spots or on the spot. So of course they are solids. Particles are close together, but random. They can move over each other. Okay, of course they can move over each other. So these are gases. Okay. We have finished our lesson today. I hope you understood our lesson today. Thank you so much.